Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to discuss about what is a system call and the first type of the system call, that is a process control. Here we will discuss the various system calls to wait for a process, to create a process, the single tasking environment and multitasking environment, how the process executes. A system call provides an information and interface to the services that are made available by the operating system. These calls are generally written in some higher-level languages known as C, C++. Other lower-level tasks can be written in some assembly language instructions. The system call is then divided into many categories. Today we will discuss about the first category, that is a process control. A program must be able to halt its execution normally or abnormally. If the process is continued to make a system call to terminate the processes or program's execution abnormally, or the program runs into a problem and causes an error trap, then sometimes the dump of memory is taken and the error message is generated. The dump is then written to a disk, and the system-aided programmer known as a debugger can aid the programmer to finding and correcting the errors or the bugs that may have caused the problem. Now this problem can be solved by the debugger by debugging the error. Under either normal or abnormal circumstances, the operating system must control the transfer to the invoking command interpreter. The command interpreter then reads the next command. In an interacting system, the command interpreter continues with the next command, and it is assumed that the user will revert to an error to respond to any error. In a batch system, the command interpreter seeks entirely the job, terminates, and then continues with the next job. In a GUI, a pop-up window must be alert the user about an error and ask for the guidance. These are the different ways in different user interfaces we can control the error about a process. Some systems may allow special recovery actions if the error causes. Now, if a program finds a problem in its input and wants to terminate the program, it may also define an error level. Some severe errors can be indicated by a higher level error parameter. Thus then, indicating this error level, a control of normal and abnormal termination can be combined together by designating a normal termination as an error at level 0. The following program and the user, in the use of the help of the error level, can terminate the process and next action immediately they can perform by the operating system. Now, if we have created many processes or a single process, we may want to control its execution too. Now this control requires to able to determine and reset the attributes of a process, including the job's priority, the maximum allowable limited time to a process. This can be done by getProcessAttribute and setProcessAttribute system calls. A program or a process that is executing may want to use, load and execute another process or program. This feature allows the command interpreter to issue and process and direct it by an user command or by a mouse click or by a batch command. This arises the question that where to return the control when the new program terminates. This further problem is related to that existing problem is lost, saved or existing concurrently with the new user. If the control returns to the program existing when the new program terminates, then the copy of the memory image saved must be for the existing program. And thus we have effectively created a new process or a process to be programmed multi-programmedly. And if the process is concurrently running with the existing program, then effectively we have created a process to call another process. Now this can be done by create process or submit job system call. We can terminate a process by a terminate process system call if we no longer need or incorrect process is then incurred. Now this system calls we can use to specify the processes can control its execution time too. If we have created a process or a set of processes, then we may want to wait for some time to finish its execution. We may want to wait for a time by a wait time event call, or more probably, we may want to wait for an event to occur with a wait event system call. Then the process must signal that the event has occurred with a signal event system call. Quite often, two or more processes share the data. So to ensure the integrity of the processes, that it can only one use the shared data simultaneously, not only at a time, then we can use to log the shared data. This can be done by acquire log and release log simultaneously system call. By acquiring log, we can ensure that one process at a time can write to the shared data. And when that writing is complete, we can release the log using the release log system call. Now there are too many facets and variations of controlling a job or a process that we want to exemplify it with two different systems. Number one is a single tasking system and number two is a multitasking system. Microsoft operating system DOS is an example of a single tasking system in which a command interpreter is invoked at the time of computer is starting. And as it is a single tasking system, a simple method is run to load the program into the memory and no processes are created. The program is then loaded into the memory and executing it. The instruction pointer is then next moved to the first instruction of the program and the program is then executed and may cause an error trap. Now this terminates the program normally or abnormally. In either cases, the error code is saved for later usage. Then the rest of the command interpreter, which was not overwritten, resumes its task. Its first priority is to reload the rest of the command interpreter from the disk, and then the command interpreter made the error code available to the following program or to the user. The next type of operating system we will discuss now is a multitasking system. A FreeBSD is an example of a multitasking system in which two or more command interpreter can concurrently run together to execute the programs. When the user logs on to the system, a user-user interface choices is run. Then the command interpreter is running while other program is executing, as FreeBSD is a multitasking environment. This multitasking environment allows us to create new processes by the shell to make a fork system call. Then the program is loaded into the memory and executed with the exec system call. These system calls are then used to execute the programs readily. Depending on the way the command was issued, the program then terminates or runs in the background. In the latter case, the shell immediately requests for another command. Now the process that is running in the background cannot input the receive directly from the keyboard as the resource is being used by the shell. This I/O can be done through the GUI or file systems. Now the process can terminate and the error code is saved for the later usage, just like a command interpreter in a single tasking environment. As it is a multitasking environment, the user may ask the shell to run another program to monitor the processes, the running, the changing program's ability and priority. Now, as all the processes has completed, the exit system call may want to terminate the process and completes the execution. In this way, two of these multitasking and single tasking environment can be performed on process control to achieve the smooth and relieved and reliable execution of the programs. That is all for the process control of a system call. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.